Okay, for this example, we want to calculate the Laplace of f of t in here, and we want to prove the Laplace of f of t would be equal to 4 over s minus 3. For this paper, we're just going to use the definition of Laplace, which is Laplace of f of t would be equal to integral from 0 to plus infinity e to the minus st times ft dt. Now we're just going to substitute our f of t, which is 4 times e to the power of 3t, into this equation, and we will have times 4e to the power of 3t dt. Now, as you see in here, 4 is a constant number, so I can bring it out of the integral. And also, we will be left with e to the power of 3t and e to the power of minus st. And these two exponential functions, as you see in here, they have the same base. So in order to multiply these terms, we're just going to add their powers. So it would be e to the power of minus st plus 3t dt, and the boundaries would be from 0 to infinity again. And in order to simplify the equation inside the integral, I'm just going to factor out t from the equation. So it would be e to the power of minus s plus 3 times t. And we have dt. It is from 0 to plus infinity again. Okay, now in order to solve this equation, we're just going to use substitutions. We know that minus s plus 3 times t would be equal to u. And we know that du, which is the differentiation of this u in term in here, would be equal to dt times the coefficient again. And we're just going to substitute these values into the integral. So we will have 4 times e to the power of u, because this term minus s plus 3 times t would be equal to u. And for dt, we're just going to write du divided by this value in here. Because if you look at this equation in here, and if you divide both sides of the equation by the value of minus s plus 3, you will be left with dt on the left hand side, and that would be your dt value. So it would be du divided by minus s plus 3. Now we just have to calculate the boundaries again. For calculate the boundaries, we know that t itself is from 0 to plus infinity. We want to know now what is the boundary of u in here, right? So we're just gonna actually substitute the values of t into this equation in here, because this equation is in term of t, and we can get the boundaries for u as well. So if t is equal to 0, if I put 0 in here, it would be 0 times this term inside the parentheses, so it would be 0. So the lower boundary would be 0. And if I put plus infinity in here, u would be equal to minus infinity. Why is that? The reason for this is because if minus s plus 3 is a positive value, and you just put plus infinity in here as well, you would be left with a positive infinity on the upper boundary, which is not a convergent answer. So in order for this answer and for this integral to be convergent, you should be having a negative infinity on the upper boundary. Otherwise, it wouldn't be convergent. So in other terms, that means that the value inside the parentheses, which is minus s plus 3, should have a negative sign. That means this is a negative value. In other terms, that means s is bigger than 3 in this example. Otherwise, you wouldn't actually get any solution for this integral, since it wouldn't be convergent. So after finding the lower and upper boundaries, we usually used to actually set the lower value in the lower limit and the higher value in the upper limit, right? But if you look at this integral, minus infinity which is the which is the lower value in here, is actually set on the upper limit. So we want to swap the values in here, and we want to swap the integral range in here. In order to do so, we're just gonna swap the values and write 0 on the upper limit and minus infinity in the lower limit. But if you swap the limit of the integral, you just have to apply a negative sign in front of it. So it would be 4 times minus 1, the integral from minus infinity to 0, eu du, and I can bring this term as well out of the integral since this is a constant, so it would be minus s plus 3. So I'm just going to rewrite the equation. It would be from minus infinity to 0 eu du. The value on the numerator would be minus 4, and the value on the denominator is minus s plus 3, which I can actually take away the minus signs in here and write 4 in the denominator and s minus 3 in the denominator, because this term, if you actually factor out minus and minus 1 from it, it would be minus s minus 3. This value, if you actually, for example, you want to test, you can multiply this negative 1 in here into the parentheses. It will be minus s plus 3, which is this value in here. So, and you just actually take away these minuses, which are both minus 1 in here, and just rewrite the equation as this is. So after that, we're just going to say the value inside, the value in front of the integral, it is 4 over s minus 3, and the integral of eu is equal to eu itself, e to the power of eu itself, and the ranges would be from minus infinity to 0. And for this example, you're just gonna write the value in here as well, and just gonna substitute 0 and minus infinity into it. So it would be e to the power of 0, e to the power of minus infinity. So this value would be 1, this value would be 0, and it would be 4 over s minus 3.